travels by a car from his residence to his office, which is 15 kilometers away on a straight road, in 1 hour. We can say that the average velocity of the car is 15 kilometers per hour. Does the speedometer of the car show a reading of 15 kilometers per hour throughout the journey? No. The speedometer reading was fluctuating continuously between 0 kilometers per hour at signals, 5 kilometers per hour at traffic jams, and 60 kilometers per hour on the freeway. When a body moves in a straight line, the magnitude of its velocity is equal to its speed. The speedometer reading gives the instantaneous velocity at that particular moment. What is instantaneous velocity? The velocity at an instant or instantaneous velocity is defined as the limit of the average velocity as the time interval, delta t, becomes infinitesimally small. In differential calculus, the right-hand side of this equation is called the derivative of x with respect to t. It represents the rate of change of position with respect to time at that instant of time. We can obtain the value of instantaneous velocity either from the xt graph or numerically using differential calculus if the relation between x and t is known for the motion. Let's understand how to calculate instantaneous velocity using an xt graph. We first mark a point P on the graph at which the instantaneous velocity of the body has to be found. We mark 2 points P1 and P2 on either side of P. Join points P1 and P2. Find delta t and delta x. When delta t is reduced, we get lines Q1, Q2, etc. On further decreasing the value of delta t, we finally get one line, which is the tangent to the curve at point P. The slope of this tangent represents the instantaneous velocity at point P. Slope is represented by tan theta as shown in the graph. This graphical method of finding the instantaneous velocity at any point is cumbersome. Therefore, we generally use the numerical method using calculus for finding the instantaneous velocity at any point. Let's solve a problem using this numerical method. The position of a particle that moves along a straight line is defined by the relation x is equal to t cube minus 6t square minus 15t plus 40, where x is expressed in meters and t in seconds. What is the instantaneous velocity at t is equal to 0 second and t is equal to 2 seconds? What is the average velocity between t is equal to 2 seconds and t is equal to 4 seconds? Solution: the equations of motion are x is equal to t cube minus 6t square minus 15t plus 40. V is equal to dx by dt is equal to 3t square minus 12t minus 15. Label these equations 1 and 2. At t is equal to 0 seconds, we need to find the value of v. Substituting t is equal to 0 in equation 2, v is equal to minus 15 meters per second. The particle here is moving towards the left. At t is equal to 2 seconds, we need to find the value of v. Substituting t is equal to 2 in equation 2, v is equal to 3 multiplied by 2 square minus 12 multiplied by 2 minus 15. 12 minus 24 minus 15. Minus 27 meters per second. The particle here is moving towards the left. Average velocity is equal to x4 minus x2 by 4 minus 2. To find x4, we need to substitute t is equal to 4 in equation 1. x4 is equal to 4 cube minus 6 multiplied by 4 square minus 15 multiplied by 4 plus 40 is equal to minus 52 meters. The particle is situated to the left side of the origin. Similarly, to find x2, we need to substitute t is equal to 2 in equation 1. x2 is equal to 2 cube minus 6 multiplied by 2 square minus 15 multiplied by 2 plus 40 is equal to minus 6 meters. The particle is situated to the left side of the origin. Average velocity is equal to x4 minus x2 by 2 minus 52 minus of minus 6 by 2 is equal to minus 46 by 2, which is equal to minus 23 meters per second. Therefore, the average velocity between t is equal to 2 seconds and t is equal to 4 seconds is minus 23 meters per second.